Welcome to this lesson on heat transfer. Heat transfer is one of the most fundamental concepts in thermodynamics. In this video, we will explore the three primary methods through which thermal energy moves from one place to another: conduction, convection, and radiation. Understanding these mechanisms is essential for explaining countless phenomena in nature and technology, from how your coffee cools down to how the sun warms the earth. Heat transfer is defined as the movement of thermal energy from a region of higher temperature to a region of lower temperature. This is a natural process that occurs spontaneously whenever there is a temperature difference between two objects or regions. Heat always flows from hot to cold, never in the reverse direction, unless external work is applied. This fundamental principle governs all heat transfer phenomena and is a consequence of the second law of thermodynamics. There are three distinct methods through which heat can be transferred. The first is conduction, which involves heat transfer through direct physical contact between particles. The second is convection, which involves heat transfer through the movement of fluids such as liquids or gases. The third is radiation, which involves heat transfer through electromagnetic waves that can travel even through the vacuum of space. Each method operates under different physical principles and plays a crucial role in various natural and engineered systems. Conduction is the process of heat transfer through direct contact between particles of matter. When particles at higher temperatures collide with neighboring particles at lower temperatures, they transfer kinetic energy. This causes the slower particles to vibrate more rapidly, effectively transferring heat through the material. Conduction requires physical contact between molecules and does not involve any bulk motion of the material itself. It is most efficient in solids, especially metals, because their particles are tightly packed and can transfer energy quickly through collisions. Conduction occurs all around us in everyday life. When you place a metal spoon in hot coffee, the handle gradually becomes warm because heat is conducted from the hot liquid through the metal. When you cook food in a pan on a stove, heat is conducted from the burner through the pan's material to the food. If you hold an ice cube in your hand, it melts because heat is conducted from your warm hand into the cold ice. Even the heat that escapes through the walls of your home during winter is transferred by conduction through the building materials. Convection is the process of heat transfer through the bulk movement of fluids, which include both liquids and gases. Unlike conduction, convection involves the actual physical motion of the fluid itself. When a fluid is heated, it becomes less dense and rises upward. The cooler, denser fluid then sinks downward to replace it, creating a circular motion called a convection current. This continuous cycle effectively transfers heat from warmer regions to cooler regions. Convection requires the presence of a fluid and cannot occur in solids. Convection is responsible for many important natural and technological processes. When you boil water in a pot, the hot water at the bottom rises while cooler water descends, creating a circulating pattern that distributes heat throughout the liquid. Sea breezes and land breezes are caused by convection currents created by temperature differences between land and water. Your home heating and cooling systems rely on convection to circulate warm or cool air throughout the rooms. Even large-scale atmospheric weather patterns, including winds and storm systems, are driven by convection currents in the atmosphere. Radiation is the transfer of heat through electromagnetic waves without requiring any medium or physical contact. Unlike conduction and convection, radiation can occur through a complete vacuum. All objects emit thermal radiation based on their temperature, with hotter objects radiating more energy. The sun heating the Earth is the most familiar example of radiation, as the sun's energy travels through the vacuum of space to reach us. Radiation does not depend on the presence of matter between the heat source and the receiver, making it fundamentally different from the other two methods of heat transfer.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.